Welcome to Hartman Math. This is lesson 8.2 Arithmetic Series, where we take an arithmetic sequence that we were looking at in 8.1 and we add up the terms. So example number 1, find the sum of the counting numbers from 1 to 100. Counting numbers also known as natural numbers, 1, 2, 3, 4, etc. So if we kind of start to write this out, kind of see what it looks like, it would be 1 plus 2 plus 3 plus, and obviously some more, 4, 5, 6, etc. We show the ellipses, the dot, 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 to say the pattern continues. We keep going at 98, 99, and 100. So this is kind of a classic problem. It kind of goes back in textbooks to Germany in the 1700s, early 1700s. We're talking about a man named Carl Friedrich Gauss, who was kind of a child then. And the story is that this problem was given to those students, and he came up with the answer right away. As his classmates were just kept adding them up, 1 plus 2 plus 3 is 6, add 4 is 10, add 5 is 15, and so on. He looked for pattern. And what he saw was that if he adds the first and the last number, he would get a sum of 101. And then if he adds the second and the second to last number, he also gets 101. And that pattern continues. So all we have to do now is figure out, since the sum of each of these pairs is 101, how many pairs of numbers are there here? Since there's 100 total, there's got to be 50 pairs. So he just did 50 times 101 and got the sum to be 5,050. And that approach is actually our formula for an arithmetic series. So here's our formula. S, capital S, for sum or series, sub n tells us how many things that we're adding up, is equal to the number of things we're adding up divided by 2. Here it was 100 divided by 2. That's the 50 that's right there, times first term plus last term. 1 plus 100, and that makes the 101. Example number 2. Find the sum of the first 31 terms in the series. So for that, we need to know how many things, n, right there. First one and last one. So if we're talking about adding up 31 terms, we need to know what the 31st term is. So that takes us back to the 8.1 lesson, where we did a sub n is equal to a sub 1 plus n minus 1 times d. First term is 10. 31 minus 1 is going to be 30. Common difference, it's going up by 3 each time. If we make that calculation, we get that the 31st term is 100. Now we're ready to do S sub 31. Number of terms divided by 2, first and last. And when we say last, we're talking about the 31st one that we just found. So we're ready to hit that into the calculator, and you should get 1,705. All right. You try this one. Find the sum of the first 42 terms. Pause the video here as you work it out. All right. So the challenge here, as you can see, it's going down by 6 each time, so D is negative 6. A sub 42 is 14 plus 41 times that D of negative 6, and we would get negative 232. Now S sub 42 is going to be 42 divided by 2 times first plus last. And you should get a sum of negative 4,578. Example number 3, find the sum. Well, this time we know the first term and we know the last term. What we don't know is how many. And what is not intended is to try to write it out and just kind of do it by guess and check and exploration. You have to show the algebra to get there. So again, we go back to the 8.1, and the focus is on this term right here, the last term, the 231. Because what we're looking for is the position of that term, the n that belongs to it. So we're going to use our a sub n formula. A sub n, 231, is equal to a sub 1 plus the unknown n. We don't know what the n is for that term, minus 1, times the common difference of 4, going up by 4 each time. So we're just going to solve. So let's subtract the 11 from both sides. Let's get rid of the 4. We're talking about undoing multiplication, so let's divide both sides by 4. And then the parentheses are no longer needed, so we'll just add 1 to both sides. There's our n, the one thing that we needed to know. That's the 56th term. So we're going to do s sub 56. Now we know everything. We know n, we know a sub 1, we know a sub 56. You can type those in. Do that on your calculator. You're going to get 6,776. Sigma notation. So this is the Greek capital letter sigma. And for our problems here, sigma means find the sum. So we're just going to do a series. If the expression inside kind of looks like an mx plus b situation where it is linear, that tells us that we're talking about an arithmetic series, the one that we know how to do at this point. This is known as the lower limit of summation. It essentially tells us what to plug in first. It means plug in a 1. 5 times 1 minus 2 would be 3. So 3 is the first term in the series. If we want to know the next one, you can plug in a 2, and then plug in a 3, and so on. The number up top is the upper limit of summation. It tells us where to stop. We stop when we would plug in an 8. So as I said, plug in a 1 and you get 3. Plug in a 2, and we get 5 times 2 minus 2 is 8. If we plug in a 3, 15 minus 2 is 13, and so on. So as we go to find the sum, s sub 8, if we start counting at 1 and stop counting at 8, that's 8 things for us to add up. So that tells us that n is 8. And here's our first term. The last term would be found by plugging in an 8. So 5 times 8 minus 2 would be 38. And I think that's pretty much all we need to know. We've got n, we've got first term, we got last term. We're ready to use the formula. S sub 8, 8 divided by 2, 3 plus 38. Calculate. You get 164. That's it for today. I'll see you next time.